Okay, welcome back, everybody. Were you pretty good? What did you think of translations?
Easy.
Moving stuff around by translations?
Yes.
We're good. Do you understand the notation of like xy goes to x plus 2 and y minus 4?
At first, I mixed it up and I wrote it as like a slope form.
Ah, yeah, it's not a slope form.
Yeah.
Careful with that. This is what you would call a mapping. This is kind of a big word in math. You will run into it if you take more math classes. You're mapping the coordinates xy onto x plus 2, y minus 4. You will study mappings and other topics in math. Okay, what about this transformation here? It says, describe the transformation of the polygon as it moves from the left side of the coordinate to the right. So basically they're asking what happens to this as it transforms into this. What's one thing you know it has to do, Shafoni?
Reflect
It has to reflect over what type of line?
the y-axis.
Well, there's no axes on there, so what type of line is the y-axis? A vertical line. You know it has to reflect across a vertical line. So where could we draw that vertical? Let me clip this in so we have it. So we have this right here. If I clip this in, if I draw a vertical line, where would it have to be?
3 spaces away from the goal.
3 spaces. Very good, very good. So we know that this sucker has to be something like this, right? It's not going to be quite I'm doing, oh wait, I can move it over, right? There we go, good. Nice, so we know it has to reflect over M. And if we do that, where's it going to go? It's going to go right to here. Now what should I do? Yeah.
Find the scale factor.
Find the scale factor?
Triangle.
Why do we know that there has to be a, what kind of operation then? So we did a reflection, then what? If the first transformation is a reflection, what's the second one going to be? We use scale factors in what transformation? We called it yesterday. Begins with a D. Dilation, yeah. So we're dilating this. But to dilate it, we need a scale factor and we need a what? And a center, right? So did you play around with this a little bit? Did anybody play around with this? What do you think the scale factor needs to be? Around what?
3.
It looks like it's around 3. How did you get 3 as a scale factor?
Because the bottom.
Yeah, let me give you some coordinates. I'm sorry. It's hard to talk about this right here. Let's call that A prime. We'll call that B prime and C prime. Because the side that corresponds to what, Tony?
AC corresponds to.
Well, A prime, C prime, you mean?
Oh, okay. Corresponds to B and B, whatever.
Whatever that one's going to be. So you know that the corresponding side, or what you think is the corresponding side, what's the length of that? What's the length of this one? 6. So it looks like the scale factor is going to be 3. Do we have to? Does it matter a great deal what center point we choose?
No.
Yeah, we want it to end up in this space. We could make it 3 times as big, right?
But we'll end up in the same spot.
But we'll end up in the same spot, exactly. So how do we do this? What do we do? Any ideas? Yeah.
Put the center point 4 spaces below A prime.
4 spaces below A prime? Okay, so if we go 4 spaces below A prime, that's totally fine. So if we do this, so we put it right there. So let's say we put the center point right there, right here. We want to move A actually to B prime. What would the scale factor be if we did that? Yeah?
4.
Is it getting bigger or smaller?
Bigger.
It's getting bigger, so the scale factor needs to be greater than 1. What's the distance from here to here?
4.
4, but we want the distance to be?
8.
What's 8 over 4?
2.
2. So if we did that, yes, A prime would move to there, B prime, which is actually where we want it to move. But we want B prime to move how many spaces up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want to move 12 spaces up. How far is it from the center right now? It's only 8 up. If we use the scale factor of 2, how far up would it move? What? It would move 8 up. It'd be a 16 distance from it, right? Is that far enough? Not quite. Also, if we did this distance right here, you see the ray right there? We want it to actually go through that. So that's a really good guess. Finding the proper center point, is that going to be pretty hard?
Yeah.
It looks like it's pretty tricky. What other thoughts do you have there?
If you put it 2 to below A prime.
If you put it 2 below A prime, right there. Okay. So it goes up to, so it goes like this. Oh, look at that. So is that on the right line right there? That'd be a scale factor of, let's call that C double prime right there. AC double prime over AC prime is going to be what? It's going to be 3 because it triples in length. And what about AB prime? Sorry, excuse me. That's not A. What do we want to call our center point, this bottom point right here? Let's call it X right there. X to C prime over X to C double prime is 3. But what about X to A prime, X to A double prime? That's this one right here. Over X to A prime. What does that look like it is? Well, what's the distance from here to here? 2. What's the distance from X to A double prime?
4.
This is 2 and this is 4. So what's it together? 6. So it also equals 3. Does that match so far? Yeah, it's pretty cool. What about A to B prime? That's 6, and we already said that this distance is what? 12. So that's also, and this right here is B double prime. X to B double prime over X to B prime is 3. So does this work? Yeah, so if K is 3 and the center is 2 below A, and it was the reflection across line M, does that work perfectly? Yeah, the other one down 4 worked for one of the points, but it was a little off for the other ones. It didn't go high enough for B prime, and it was off course. Remember, it was off like this? So what do you have to do? You really have to test it. And is this the only way to do this?
No, I have a question.
Yeah, there's probably many others. Yes.
Could you take...
Okay, Lynch, A. What'd you get for 1? Sorry. What? CD. What'd you get for 2? Eberhard? HM? HL? Hammer, what'd you get for 3? GE? Jackman, what'd you get for 4? What'd you get for 5? Etienne, what'd you get for EL? Does anybody want to challenge? What? FEL? IAH? Like that? Does anybody want to challenge any of those? We have a challenge coming from Missy. Yes. Which number? Number 6. Okay. 180 degree. So what are we going to need? I'm going to actually have to bring in the picture. That would help to do this question. Of triangle BCI. Triangle BCI. So B, C, and I. So what's that triangle going to be? There's BCI right there. What are we rotating around? O. So if we rotate 180 degrees around O, what's BI going to become if you do 180 degrees?
Okay.
What do you think? If you took this and rotated it, what would it become? It does become this right here. And what does C become if you rotate it 180 degrees? G. So this is C goes to G. What does I go to?
K.
Yeah, I goes to K, which means that B goes to. So you end up with this triangle. So what does this actually correspond to? Not FEL, it goes to triangle. What? FGK. Does that make sense, everybody? If you put a tack in the board and you rotated it, that's what it would become. Does the order of the letters matter? Very much so. Would it be proper if I said this was GKF?
No, because that wouldn't be rotated 180 degrees.
Well, it would be a rotate, but it wouldn't correspond. Like F corresponds to B, G corresponds to C, and K corresponds to I. If I change the ordering of one of them without changing the ordering of the other, they're no longer rotations of each other. Does that make sense-ish? Okay. Any other challenges?
Yep.
Tyler, yeah.
Number 4.
Number 4, it says 90 degrees counterclockwise of FL about H. So FL about H, 90 degrees. FL counterclockwise about H, right there. Counterclockwise is to the left. So what is L going to map to? I, and F is going to map to So, does it work?
Yep.
Yep. FL does go to BI. Yep.
Yeah.
Lynch. 5. So that was actually correct. 180 degree rotation of KEF about O. KEF about O. I'm going to kill this drawing with some more color. KEF. So KEF. There's KEF right there. About O, and it's a 180 degree rotation. So if we did 90 degrees, where would it be? It would be right here, right? Do you agree with that? It goes up, and then do 90 degrees more. What's it going to do?
Correct.
Correct. So let's just think about this for a second here. Draw.
I don't think it would go there.
What does F map to? F maps to D. And then what's D going to map to? What? Someone said it. B. Yeah, it does map to B. E goes to C. And then what does C map to? A. K goes to J, and J goes to I. This was number 5 we were doing that I was killing with this terrible, terrible coloring. So what does it actually go to? So we said that F goes to A. So what does this actually go to? Triangle. What does K go to?
A.
K goes to I. What does E go to? A. And F goes to B. Cool. We feeling it now? I like this question a lot. It really forces you to rotate in your head. Any others you want to challenge?
Oh, no.
Okay. Fine. You must have the images on the ray, and the ratio must be constant for all of the points. If they only give you 4 points, how many points do you have to test?
4.
4. Do you test any other points? No. You can estimate it with like drawing a line, but those are the 4 you test. Do you understand why it's root 2, everybody? This 1 squared plus 1 squared is 2. That's important.
So why did you